I want to demonstrate how we can use this simulation to explore forces on a ramp. My students are going to select an energy graph, which gives you total energy, potential energy, kinetic energy, and thermal energy, which should be 0 on the ramp because I'm asking them to start off with it being frictionless. They're at the top of the ramp at a 10-degree angle. We're going to hit go, and we'll see it slide down the ramp and eventually crash into the wall where all the energy turns into thermal energy. I'm going to pause it, and I'm going to bring this slider right back to this point here where I'm going to set the potential energy to 0 and see that all the total energy has become kinetic energy. Given this fact, and given the fact that we have a parallel force down the ramp, we can get from the kinetic energy, from the velocity right here, we can get the acceleration down the ramp, and knowing the mass, we can get the net force, and then that will help us get the parallel force that drives it down, drives the object down the ramp. Once students collect a few samples of what's happening in the frictionless environment, they should be able to come up with a rule for determining the parallel force, and then they can move to the not frictionless version of this and start to incorporate the frictional force, which is of course dependent upon the normal force. And here I've got an example ready to go. At 10 degrees, the friction is too great to see any motion, so I'm just going to increase the angle until I get some motion here, and students can kind of play around with this to begin their study of the frictional and the normal forces.